last section, this kind of ties into what we did yesterday. Yesterday we solved linear equations. Today, our main topic is going to be linear inequalities. The one thing I will say about linear inequalities is that we've done these before, okay? You're going to solve it, you're going to graph it on a number line, because these are just like the one variable, not the coordinate plane ones. And when we write our answer, we're going to write our answer in interval notation. So that's going to be the part that's a little bit different. Instead of just saying x is greater than 2, that would be our solution, but then we're going to write it in interval notation. And then we're going to use that interval notation to put our answer on a number line as well. So we're going to use brackets, we're going to use parentheses, and we're going to use those things. So that's going to be the one thing that's a little bit new that we've never really done before. But it's still the same idea, and we're still solving it the same way. Okay, first example. Three x minus 5 is less than 6 minus 2x. Okay, we're going to see simple inequalities today, and that doesn't mean that they're simple, it just means that it's a single inequality. And then we're also going to have some that are compound inequalities, so we're going to have more than one. So we're going to talk about the difference between those two and how we express that or write that as an answer. This one we're going to solve it just like we did yesterday with an equation, right? Our goal is get x's on one side, get the numbers on the other side. What I would say is, because we're doing an inequality today, I always like to finish on the left-hand side with my variable. Because when the variable's on the left, that's going to help us decide which way we're going to shade that inequality. And if you solve it and it's on the right, then you can always flip-flop it at the end to finish it on the left. But it's always easier to finish on the left, so that way it makes more sense which way to shade. In this case, we're going to probably just move the 2x over, make it positive. Since I'm moving x's to the left, we'll move our numbers to the right, and we get 5x is less than 11. And then we divide by 5. And we get x is less than 11/5. Once again, we're going to get some fractions and things sometimes, and we just can't avoid those. Okay, so the way that we're going to write our answer today, we're going to write our answer essentially three different ways. Okay, this would be the solution. X is less than 11/5. That means any value less than 11/5 would work. Yesterday we talked about checking our answer, right? We could still check this. Anything less than 11/5 would work. So I could pick a number out that's less than 11/5. Any number that's less than 11/5. So what would be a nice, quick, easy number that's less than 11/5 that I could use here? 2 would be good. Okay. What's even better than 2 maybe? There's one number that I always love using. 1 would be okay. 0 is always my go-to. Okay, because 0 is so easy to use. If I put 0, 0 is less than 11/5. 3 times 0 is 0. 0 minus 5 is negative 5. So the left-hand side is negative 5. 2 times 0 is 0. 6 minus 0 is 6. So negative 5 is less than 6. True statement. So that does work. Okay. If it didn't work, that means I probably have it shaded or the sign going the wrong direction. So you can still check it. Do you have to check it? It's totally up to you. But if you feel like, I'm not sure if my sign's pointing the right way or whatever, checking it is something you can still do. The good thing here is that you have a whole list of things you could check. You don't have just one number that you have to check that one number. Now I have any number that's less than 11/5 that I can use to check. So 2, 1, 0, any of those would have worked here. All right, so this is the first way that we're going to leave our answer. The second way we're going to leave our answer is on a number line. I like to do the number line first, and the order that they tell you to put the answer in doesn't necessarily matter a whole lot, but I like to do the number line first and then express the interval notation last, and I'll show you why. All right, 11/5 is going to be just a little bit bigger than 2. Between 2 and 3, a little bit closer to 2. Hey, we've talked about interval notation. Now, we're not going to put open circle, closed circle anymore, okay? We're going to put either brackets or parentheses, and if I have a less than symbol, which symbol do we want, brackets or parentheses? Parentheses, right? Parentheses means not included, and I'll put that up here again. Parentheses means not included. That's the same as an open circle. Okay, brackets means included. And that would be the same as the closed circle that we've used in the past, just so you can kind of draw some similarities there. Okay, so now here's what we have to do. 11/5, and we're going everything to the left of 11/5. So we're going to do an parenthesis. And I would just label this as like 11/5 right here so we know where we're at. And then everything left of that, or to the, or less than. So we just shade it to the left, put an arrow, so it's going to keep on going. Okay, so we have the answer expressed, we have the number line, and then the last thing we're going to do is we're going to express it in interval notation. Here's why I like doing the number line first, is because how far left is this graph going to go? Forever, right? And we know that we call this negative infinity, all the way to the left. Negative infinity is all the way to the left, positive infinity is all the way to the right. So what we're going to say here is negative infinity all the way up to 11/5, parentheses on both sides. Infinity, whether it's positive or negative, will always have a parenthesis next to it. Okay? This one has a parenthesis next to it because that's the way it is on the number line. So we're just graphing the number line and putting it in interval notation. Okay? So everything from all the way to the left up to 11/5. That's why I like to do the number line first. You could flip-flop them if you want, but that's the easiest way I think it is to do it. Okay. A quick reminder. If we had a problem like this, okay, it's just a two-step inequality. We're going to solve it just like we did yesterday. We're going to subtract 4 from both sides. And we're going to divide by -3. But when we've solved inequalities in the past, what do we always have to remember when we multiply or divide by a negative? The sign's got to flip. That sign has to go from greater than to less than. Hey, the reason it has to flip is because we're saying anything less than -4/3 is going to work. Okay? If I hadn't flipped it, then it would be anything greater. Well, 0 doesn't work here. -3 times 0 is 0. 0 plus 4 is 4. 4 is not bigger than 8. So the numbers to the right of -4/3 are not solutions. If I wanted to check it, I would have to check a number that's like less than -4/3. So, for instance, -2 could work. -3 times -2 would be 6. 6 plus 4 is 10. 10 is bigger than 8, and that would work. Okay, so anything less than -4/3 should be a solution. Okay, if we were to graph this one real quick again. Okay, -4/3 would be between -1 and -2. If you're not necessarily sure where it's at, change it to a decimal. Changing it to a decimal is probably the best way to kind of decide where am I going to put it. And this doesn't have to be real specific here. I'm not asking you to get super specific, but we do want to place it on the right side of like 0 especially and put it in the right spot. And then it's going to look very similar to the one we did just a second ago. It's got a parenthesis because it's less than, and then we're going to shade to the left. And once again, we would say negative infinity up to negative 4/3. Hey, and I point this out because whenever we solve an inequality, we have to ask ourselves, did we ever multiply or divide by a negative? Okay, and that's probably the thing that probably gets left off more than anything else, is forgetting to flip the sign when we multiply or divide by a negative. If we don't multiply or divide by a negative, the sign doesn't have to flip. But it's easy to forget, especially if you have one that's like 3 or 4 steps long that I have to solve out. You just got to keep asking yourself, did I ever multiply or divide by a negative number? Okay, one more simple inequality. We'll talk about a few other things, and then we'll talk about some compound inequalities. Okay, once again, trying to get x by itself. We have some options here. Okay, one option would be to add 7x over here to make it positive. And that's kind of like what we talked about yesterday. We could move the 10x over here because we talked about putting the x on the left today. So we have a couple of options. Neither one of them are necessarily right or wrong. It just kind of depends on what makes the most sense to you. What would be easiest for you. Okay, most people kind of like keeping the x positive, and I don't have a problem with that. So now we have 17 is less than or equal to 17x. Still trying to get x by itself. So to get x by itself, we're going to divide by 17. Okay, we still haven't multiplied or divided by a negative, so the sign doesn't need to flip. But here's kind of like what I was talking about early on. If the variable ever ends up on the right, we want to flip that, right? Because right now, this sign is read less than or equal to, and the mistake that's going to get made here is I'm going to see people shade it to the left, okay? But that's only if the variable is on the left with it. So what we really want to do is everything flipped here. And we'd rather write it like that. Okay. There's nothing wrong with leaving it like this if you can kind of visualize where that graph's going to go. I always think it's best just to put the variable on the left, flip everything. Because I'm flipping x to the left, the sign's going to flip, 1's going to flip, everything switches. Okay? And so I always like to finish with the variable on the left. Now, if we were to write our answer here, graph it first, we're going to start at 1. What kind of symbol do we want here? We want a bracket because we got equal to, okay? The way I like to remember it is when I see the equal to, that means we're going to close that bracket off. We're going to make, it's not going to be rounded like a parenthesis. And so we're going to start at 1 with a bracket, and then we're going to shade it to the right. Everything from 1 to infinity. Here we're including 1. That's the big difference, is when we have a bracket, 1 is included. That means 1 would satisfy this inequality, as well as anything to the right of 1. When I write my interval notation here, we're going to start at 1, and we're going to the right forever. And once again, infinity always has a parenthesis next to it, because you can't stop at infinity. Infinity is never going to be a stopping place. It just goes on forever. So it's always going to have a parenthesis. Okay, so those are just one step or one variable inequalities where we just have one inequality. We're going to shade it to the left, we're going to shade it to the right. Before we go on to compound inequalities, there's one other thing that we're going to see that uses inequalities. you're going to have a problem or two today where it's going to ask you for the domain, okay? And you're going to express the domain as an inequality because the domain is going to be a lot of different things. It could be a big range of values. So it's not just one particular number. And that's kind of what we saw earlier in the chapter as well. We try to express the domain as like all real numbers or whatever it might be. Well, when I have a square root, we're taking the square root of something. As of right now, what kind of number can I not take the square root of? Can I take the square root of 0? What happens if I take the square root of 0? Try it. See what happens. Can I take the square root of 0 in your calculator? See what it gets. You get 0, right? Square root of 0 is 0. 0 times 0 is 0. Okay, that's okay. Can I take the square root of 4? Yeah, or any positive number? Yeah, that would work. Can I take the square root of negative 4? No. Okay, that gives me an error. Okay, and until later in the chapter, we don't have to worry about the good old imaginary numbers, right? Where we take the square root of a negative. So that's the good thing for right now. We're going to stick with the real number system right now. We're going to act like we don't even know anything about imaginary numbers, even though that's everybody's favorite topic, right? I know you guys are disappointed to know that there's no imaginary numbers yet. But we're not going to worry about that yet, okay? We're going to stick with the real number set, okay? And when I take the square root of something, I can take the square root of anything 0 and above, right? And so what we're going to say here is that this expression, x minus 6, can be anything greater than or equal to 0. But we're going to try to figure out what value of x is going to make that happen. So we got to solve for x. Pretty easy one to solve. We're going to add 6 to both sides. And we're going to say x is greater than or equal to 6. Okay, and if we had to do it on a number line or do all that, on this one I'm just going to write it in interval notation. I'm not going to put it on a number line, but everything from 6 to the right. Okay, and just understand what's going on here, right? Because we're saying if I plug in 6, we're including 6 because it's a bracket. 6 minus 6 is 0. I can take the square root of 0. If I plug in like 7, 7 is to the right of 6. 7 minus 6 is 1. The square root of 1, still 1. But if I put a number that's less than 6 in here, like 5, 5 minus 6 is negative 1. And when I try to take the square root of negative 1, it's going to give me an error. We can't do that, okay? So any number 6 and above is okay to plug in here. It's okay for my domain. It's okay for my x value. Okay? So that's all we're doing there. It's just simply asking us domain, which we've had a lot of questions about domain so far in chapter 1, and we're going to continue to see a lot of questions that deal with domain throughout the semester. It's going to be a really big topic in college algebra. Okay? And that you don't the function can change, that we can have different kinds of functions, but our goal is to figure out what values of x are good. Okay. Now we're going to get into compound inequalities. Still have inequalities, but when I add that word compound to it, means we're going to have more than one. So instead of just having x is less than 3, we're going to have x is less than 3 or x is greater than 5. Or sometimes we have the word and in there. So there's two different words that we're going to see. We're going to see and we're going to see or. And we're going to do some examples of each one. And means it has to be true for both inequalities. Okay? It has to be true for this one and it has to be true for this one. Or means it has to be true for either inequality. It could be true for this one or it could be true for this one, but it doesn't necessarily have to be true for both. So there's a big difference between those two. And there's going to be a difference in our answer then as well, and we'll talk about how we can express that. All right, so let's start with and. There's a couple of different ways that and problems can be written. But typically, this is going to be the most common way. It's all written as one big combined inequality. And we know that this is a compound inequality because we have multiple inequalities within the same problem. Hey, I'm just going to show you this, and not that we have to rewrite it like this, because I'll show you, I think, what the easiest way is to graph this. But if we were to separate sometimes this inequality will be written like this instead. They mean the same thing. They're going to be written both ways. This is probably the easier way to do it because it's a little bit shorter. It's kind of more concise. But you'll see it the other way as well. So I just want you to see both. On this one, we have to put the word and in between because there's two separate inequalities and we're saying and. It has to be true for both. This one does not have the word and in it, so it's an assumed and. If there is no word in that inequality or compound inequality, then we're going to assume it to be an and statement. Okay? So the best one to solve, if I had to choose between this one I'd have to solve both of these individually. This one's going to be the one that we're going to solve. Now, solving this one's a little bit different, okay? And you might have done some of these before. Our goal is still to get x by itself, right? So look at the expression that has a variable in it, 2x plus 5. So if I was going to solve an equation or inequality with 2x plus 5, what's going to be the first thing that I'm going to do? If I wanted to get x by itself. Subtract 5. Okay? Now here's the part where it's a little bit different. We're going to subtract 5, and instead of doing it from both sides of the equals or the inequality, we're going to do it to the left, the middle, and to the right. We've got to do it to all three parts because we have three separate parts, and we have to do it to all three when it's written like this. So this would become negative 8. This is 2x. The 5s are going to disappear. Less than or equal to 2. Still don't have x by itself quite yet, so we got one more step we got to do. We got to divide by 2. And then that would be our compound inequality. And we know that we're done because x is all by itself. Okay, so that's the solution, but then we need to talk about how we're going to express this on a number line and then how we're going to put it into interval notation. Okay, so let's do the number line first. We know the two numbers that we're dealing with here, negative 4 and 1. Okay, and like I said, you don't have to get real specific with your number line, but you do want to mark it. You always want to make sure the negative is to the left and the positive is to the right, things like that. Make sure you graph it correctly. Okay, negative 4 is less than x. That means we are not including negative 4 because the sign next to the negative 4 is less than, not equal to. And really the way that we're reading this is x is somewhere between negative 4 and positive 1, including positive 1. Okay? So when I draw this in interval notation, I'm going to put a parenthesis on the left. I'm going to put a bracket on the right because we're including 1, less than or equal to 1, and we're going to shade everything in between. And that would be our number line. Once again, this is something that you can check, right? There's a lot of different numbers here. Not a ton of numbers, but there's more than one answer here. Anything that's in this little shaded region should work. So I could plug in like negative 3, negative 2, negative 1. 0, that's our go-to, right? We like 0. 0 is a nice number to plug in. So let's see what happens here. 2 times 0 is 0. 0 plus 5 is 5. Is 5 between -3 and 7? Sure enough, okay, and it works. And that would be true for any of those numbers in that little shaded region. So that's how you would check it. And especially if you're not sure, checking is always a good thing to do. Okay, the last step now is to write it in interval notation. So to finish this out in interval notation, we're going to go parenthesis, -4 to 1, including 1 with the bracket. And that would be our interval notation. But how easy is this if we already have a graph, right? Because I'm just taking this symbol at -4, going all the way to 1 with the bracket. We're basically just copying the number line down into the interval notation. So that's why I like to do the number line first. I think it makes sense to put it on the number line, and then it's easy to make interval notation if you have everything right. Okay, questions on that one? That's really the biggest difference here, is that we're going to have basically 2 endpoints typically on an and statement. Ors are going to look a little different. All right, let's look at an or statement. When it's an or statement, it's going to have the word or in between, okay? There's no exceptions. If it's or, it has to have an or written in there. They're going to give us 2 separate inequalities, and you're going to put or in there. And then we're just got to solve each one separately. So it's just solving 2 different inequalities. We're going to add 5 to both sides. We're going to divide by 2. First one solved. Okay, I'm going to go ahead and bring the or statement down here. Second inequality, basically it's the same steps, right? We have the same expression, 2x minus 5, so we're going to add 5 to both sides. It doesn't always have to be the same expression. And then we divide by 2, and we get x is greater than 3. Okay. So the solving of it shouldn't be all that difficult. Sometimes it'll be harder than that, but here's our 2 separate inequalities, but we have the word or in between. Now, here's the thing that should happen most of the time. There are exceptions to the rule, but most of the time, ors will go opposite. Okay, so you kind of think about O and O. Most of the time, not always, not 100% of the time, but most of the time, ors will go away from each other. Okay? So if we were to graph this one, we're going to start by putting -1 and 3 on the number line. -1 is going to be a closed circle going to the left, or I should say bracket, not closed circle, but same thing. X greater than 3, it's not equal to, so it's going to be a parenthesis, and it's going to be shaded to the right. These 2 graphs never touch one another, and most of the time they won't on an or statement. Ands will typically meet in the middle or come together. Ors will typically go away from each other or opposite. Okay, so that's our number line. Now we're trying to identify our domain and interval notation. Okay, how far left is this graph going to go? Negative infinity, right? It's going to keep going forever to negative infinity. So as we write interval notation, that's really kind of how you approach it. I'm going to start all the way to the left, kind of like I read a book, right? Starting all the way to the left, and then we're going to come across, and we keep coming across on the number line until we get to -1. At -1, we have a bracket. Okay, and then we saw this symbol last week as well when we wrote domain for some things. We put a little U symbol in here. It's going to link the 2 different interval notations together because there's a gap in the graph, right? Nothing between these two is working. So we're going to say we're going to have a little bit of a space here. So that's where the U symbol comes in. And then we're going to start over again at 3. And we're going to go to positive. And that would be our interval notation. And that'd be an OR statement. Once again, if you checked this, okay, what would be a number I could use to check this? Can I use 0 here? No, 0 is not in the shaded region, right? So 0 would not be a number I could use here. What would be a good number I could use? Okay, 4 would work, okay? But what's going to happen is 4 is going to satisfy this inequality, but it's not going to satisfy this inequality. So that's what we're saying. It doesn't have to satisfy both. If I were to plug in a number like -2, it's going to work for this one, but it's not going to work for this one, okay? It does not have to work for both. So don't think it has to work for both. It only has to work for one or the other, okay? And that's why ORs are also a little bit different. So checking it is still possible, but just making sure you understand how you could check it or what I would need to do when I check it. All right, the last thing to finish up here, I just want to show you a couple of special situations that could pop up. There would be a ton of these, so I mean, I'm not going to give you every single example you could ever think of, because we could be doing it for a while. But I'm going to show you probably 2 of the most common types of special situations. All right, the first one, x is less than 2 and x is greater than 5. And I'm just going to give you some real basic inequalities. We're not going to do any solving or anything like that with it. But I just want you to understand what the inequality is saying. What numbers are less than 2 and, at the same time, greater than 5? Yeah, there's nothing, right? Because numbers less than 2 would be like 1, 0, negatives, right? Numbers bigger than 5 would be 6, 7, 8, 9. There is no numbers that work for both of those. And that's what happens with and. On an and statement, we have to find numbers that work for both, okay? There are no numbers that work for both. And so what we would say here is no solution. Okay, if you were to do a number line, what am I going to put on that number line? Nothing. It's just going to be an empty number line because there's no numbers that satisfy it. So if it asks you to put it on a number line, it's just an empty number line because there's no numbers there that work. Okay? So this would be the symbol that we use, and that would be what the number line would look like. Okay, the second one and the last one that we're going to talk about, if we said x is greater than 2 or x is less than 5. Okay, very similar to one we just did, except this one's an or. Okay, I think about x greater than 2. So that means everything from 3 and above, right? If I think x is less than 5, that would be everything below 5. If we put this on the same number line, two is here, 5 is here. Here's probably the thing that happens the most is a lot of people think it's just going to be everything between 2 and 5. Okay, those numbers work. 3 and 4 work, right? But there's also, think about a number like 1. Is 1 bigger than 2? No. But is it less than 5? Yeah. And once again, it's an or, right? So it doesn't have to work for both. It only has to work for one or the other. Same thing for 6. 6 is not less than 5, but it is bigger than 2. So as long as it works for 1. So are there any numbers here that do not work? No. Everything's going to work, okay? You can't give me a number here that wouldn't satisfy one or the other. And so that means everything works. And so if we were to graph this one, all real numbers. And So the way we do that in interval notation, we saw last week, would just be negative infinity to infinity. Okay, so those are just a couple of scenarios that you might run into. Every once in a while, you might see something like that. There's a lot, like I said, there's a lot of different things that you could possibly see. Sometimes they might be going both the same direction or something like that. Yeah. Yeah. All right. Homework for today.